Hi class. In this video, I'm going to be talking about square numbers, which are also known as perfect squares. So perfect squares are integers that can be expressed as the product of two identical integers, with product meaning multiply. So what that means is, let's look at an example here. I have 16. 16 is considered to be a perfect square because if I take an integer and I multiply it by itself, in this case 4, 4 times 4 gets me 16, and that meets the definition of a perfect square. So any number that can be resulted from the multiplication of two identical integers would be a perfect square. And notice here, I wrote 4 times 4 as 4 with an exponent of 2 here. This exponent of 2 just tells me that I'm multiplying my number by itself twice. We also call these square numbers. Now, if we do practice, which of the following numbers are perfect squares? Let's look at 2. Is there a number that can multiply by itself to get 2? That's an integer? No, most likely not. So 2 is not a perfect square. What about 4? Is there a number that can multiply by itself to get 4? Yes, there is. 2 times 2 equals to 4. So this is a perfect square. 8, is 8 a perfect square? Are there two numbers that can multiply by itself to get 8? No, I can't think of one, so that's not a perfect square. What about 12? Are there two numbers that can multiply by itself to get 12? Nope, I can't think of one. That's a nice integer number. What about 4 squared? Well, 4 squared is already up here. 4 squared just means 4 times 4, right? Which is going to be equal to 16. And it looks like, well, if 16 is a perfect square and it results from 4 times 4, then it is going to be a perfect square because there are two integers that can, or there is an integer that can multiply by itself to get 16. Now for 25, is there an integer that can multiply by itself to get 25? And in this case, there is. It would be 5 times 5. That gets me 25. So hence 25 is going to be a perfect square. And here is a list of perfect squares that may be useful for you to memorize. So for example, numbers such as 1 times 1, 2 times 2, 3 times 3, all the way to 15 times 15. These result in these perfect squares here of 225, 196, 169, 144, etc.